Okay, so the previous video was the acceleration due to gravity, or measuring gravity down an incline lab portion. Now we're going to do a calculation based off of that data. Okay, so once again, what's the first thing we're going to do? The first thing we're going to do is we're going to make a chart. X, T, VI, VF, A. Now, what do I know? What did I measure? Well, I measured that the distance that it ran along the incline was 1 meter. And when I averaged out the times, roughly speaking, I figured out the times were about 2.05 seconds. Now, in order to solve this, I need a third piece of information. Hit pause and think about what the third piece of information is. Alright. Some of you guys will have gotten that VI, the initial velocity of the cart, was 0 meters per second. When I let go, it was not moving. So, let's find the final velocity and the acceleration. Let's go ahead and find the final velocity. So if we're finding the final velocity, we're not going to use the acceleration. So that equation is going to be this one here. Okay. So we have X equals VF plus VI divided by 2 times T. Now, think about that. How are you going to arrange that for VF? So, take a second, rearrange that for VF. What I get for VF is the first thing I want to do is I want to divide everything by T, so I get X over T. And then I'm going to multiply that by 2, and then I'm going to subtract off VI, and that's going to give me VF. So I take 2 times 1 meter divided by 2.05 seconds minus 0 meters per second, which was my initial velocity, and that should give me a final velocity, which is going to be very, very, very close to 1 meter per second, because those 2's are going to cancel out. So I do 2 divided by 2.05, and I get 0.98 meters per second. Yeah, we'll call it that. 0.98 meters per second is VF. Okay. Now, the most important thing that I want to find is I want to find the acceleration. So hit pause and think about what equation we can use to find the acceleration. Okay. Now, what I want you to say is that to find the acceleration, we're not going to use VF. So the equation that does not have VF is this one, and that's a very, very useful equation. You're probably going to end up using that more than a lot of other equations. So let's write that one down. X equals VIT plus 1/2 AT squared. And now take a second to rearrange that for, well, hang on, what's one simplification we can make? Before we rearrange it, what's the simplification we can make? Okay, the simplification that we can make is because my VI equals 0, this term in the equation is going to go away for this specific problem because VI equals 0. Okay. Now, I want you to take a second to rearrange that equation to solve it for A. Okay, you should have a equals 2x divided by t squared. So a should equal to 2 times 1 meter divided by t squared, which is 2.05 seconds squared. So my acceleration should be 2 divided by 2.05 squared. I get 0.48 meters per second squared. 0.48 meters per second squared. Okay. So that, we're going to use this data in the next video because now we're going to start talking about vectors pretty seriously, and I want to use at least a full 10 minutes talking about how we're going to use some other data. I guess what I'm going to do here, just right in the last 4 minutes, so to give me a little bit extra time for the next video, we're going to make a triangle. And on this triangle, we're going to say that this distance here is 5 centimeters. But we're not going to call it 5 centimeters. We're going to call it how many meters? 0.05 meters. And that hypotenuse is 1 meter. And I'm going to want to find this angle right in there. And we're going to use that. This is a Greek theta, and it measures angles. Now, some of you guys have seen trigonometry, some of you have not seen trigonometry. We're going to call this opposite. We're going to call this hypotenuse. And that's my right triangle right there. There's my 90 degrees. And we're going to say that sine of theta is equal to opposite over hypotenuse. And so now we're looking for theta. So we actually have to say theta is equal to sine inverse of opposite over hypotenuse. So theta is going to be equal to sine inverse of 0.05 divided by 1. Okay, now let's do that on the calculator. Okay, watch carefully. To do sine inverse, here's my sine button right here. Right above it, it says sine to the negative 1, but I want you to say sine inverse. So we're going to do second sine, and that's going to pull up the sine inverse. Now 0.05 divided by 1 is just 0.05, so we do 0.05, we hit enter, and we get 2.86, or we're going to call it 2.9 degrees. Let's hit it again down there where maybe you can see a little bit better. Okay, so my theta is about 2.9 degrees. Alright, that's that for this lecture. And then we're going to do something with how do we expand that to calculate the acceleration of gravity in my next lecture.